All right, let's dive right in. In a previous episode, we looked at the user-defined URL, tongue twister, variable, and injected the shell context. Now we're going to be looking at the same variable and injecting it through the curl context, okay? And this is basically before we go ahead and inject the Docker container in our local environment, we're just going to be setting up some assumptions for the assignment. And these assumptions, as you'll see, well, at least in my career, have come up to be real kind of real world scenarios, so to speak. So basically, we are going to be assuming that our code that we're about to see is going to be running on a host with two processes. One is going to be a node server, okay, just to give you a little context. We'll get to that in a second. And that node server is going to have your code running on it as the developer. But there is also a file server on that host as well, okay? And and basically, this has been set up by DevOps, right, without your knowledge, and it's supposed to basically house internal only documents, okay? And it accepts traffic from the corporate network, right, on port 8081. And it is accessible over the local host interface, right, on the main server, on the overarching server that is basically serving up the two processes, the file server and the node server. So any process can interact with the file server over localhost, okay? And as I alluded to, DevOps created the server without your knowledge, right? And why would DevOps or somebody else believe that this is secure, right? Well, there's a lot of assumptions in play, okay? Because they believe, hey, it's restricted to the corporate network. That's secure, right? Nobody else can get to it. And also, okay, local host is restricted to local processes, right? And so sit back and just think about it. Is there anything wrong with this thinking? I don't know. Well, maybe I do know, but let's just play like I don't for a second. And you just kind of think about it, pause the video. When you're ready, just go ahead and go on. Okay, so the item here is just a fundamental concept of security thinking, right? And it's just the unknown unknowns are always the most dangerous. So always assume there are items that you don't know. And I'm going to keep harping on this throughout all the episodes into the future, right? So there is some items here that are kind of some unknown unknowns, and we will discover those within a second. Anyhow, the node server, as I previously spoke basically about, is there. It's housing your code, and it's publicly accessible over port 80. Okay, sweet. So all right, so go ahead and run this. You can see that the run command here, and just kind of cd into the injection fundamentals 2 directory, and then run this command, okay? So, all right, basically what you're going to be doing is the assignment is to access the file server, okay, port 8081, by injecting user-defined URL, right? And you're going to be doing it by leveraging the curl execution context, right? So think about what items can you essentially give to curl to pass in that would successfully access the file server, okay? And as a bonus, you can view the contents of sensitive, if you can, view the contents of sensitive file.txt within the file server's current working directory. So basically, the process was spawned, and the current working directory of the process is basically sensitive file is in it, right? So I'm just kind of giving you that little bit of a hint so you don't have to you don't have to be going down a rabbit hole with other directories or whatnot, doing something called directory traversal. It's basically that sensitive file.txt is right there in the root directory of basically the file server, so to speak. Okay? So think about it, give it a shot, and if you just want to pause the video, I'll give a couple of hints. Okay? All right, so let's continue. So really, when thinking about this, what network interface is leveraged for that local access, right? And we spoke upon this in the last slide. All right, so I'm going to go ahead and I have the code up here, right? And I'm going to go ahead and run this example, okay? So we see basically the what you're seeing here is right here is the essentially the assignment number one, right? And now I'm in the answer section. So we have one of the answers is commented out. So I'm going to go ahead and comment it or uncomment it. And I'm going to go ahead and save, and boom, we can see right here, kind of interesting. We see the get going through, and we actually see it coming out in the response and pulling out the content of that file, which is it's just astounding, right? So basically what we did here is instead of initiating a request, basically to a callback URL, right? We did it to a local process, and this is running through Node, but because that local host is exposed for any process on the server, we can go ahead and get to it here, which is just fascinating. So also another thing is if we go down and just here, let's see. Okay, so I just went ahead at the root. You can actually see the different files that are available at the root, or basically of the current working directory of the file server is another way to put it. So yeah, it's those vulnerabilities are very very pretty can get pretty nasty. I don't know if there's any other way to say it. Just because a lot of times that local host interface is exposed for all processes on a given server. So if you have one that's accepting public traffic, it can potentially interface with other processes that are supposedly scoped to basically non-public traffic. All right, so let's go ahead and go back. And what is this an example of? This is an example of server side request forgery. And what is it? What is SSRF? Okay. So basically, an attacker makes the server initiate a request. And as we saw, it is often to a domain that the developer isn't expecting, right? And this doesn't have to be invoked with curl. There's many libraries that basically invoke requests, and yeah, as we'll see coming up here in the slides. So categorizing SSRF, right, is the attacker exploiting curl syntax, right? Remember before we had syntactic injection, right? So is this syntactic injection? I don't know. What do you think? Well, no, this is a new type of injection that we're learning about and that you need to really look for as a developer, and I do too when I'm doing my code, is semantic injection, right? And this is, it's very powerful. So what is semantic injection? Injection that exploits a unique meaning or situation in the environment. Okay, so semantics just equals meaning. That's just another way just to kind of memorize it. So what really constitutes an environment, right? Because we're injection exploits a unique meaning, okay, in the environment. Well, what is that environment? Well, it's your code, the server, right? And the overarching environment that surrounds the server, right? So you can think of AWS, databases, etc. And you can really think of it as your code is the door to these contexts, to the whole ecosystem, right? You are the gatekeeper as a developer. It's a very powerful position. And here's a question. Can you think of a cloud service that exposes an introspection API on every server, right? Okay. So that really is AWS's EC2 metadata, and we'll see it exposes some pretty, wow, pretty sensitive pieces of information. Okay, so we're going to be looking at AWS EC2 metadata SSRF. Before we get into that, we need to look a little bit into AWS's Identity and Access Management, their IAM, right? Do a little background. So basically, IAM provides AWS's permissions functionality, okay? And say we want to give a given EC2 server, a given Linux server, some permissions, right? So we go ahead and we create those permissions and we attach them to an IAM role. And then those roles are then attached to the EC2 server. So that's just kind of the hops involved there. And this will become a little bit more clear in a second, right? So what is the SSRF risk of the EC2 metadata service? Whoops. Oh, we're back. I clicked the wrong button there. That's awesome. Okay, so what is the SSRF risk? Okay, so on the server, IAM roles can be queried through that EC2 metadata service, right? So let's suppose that a malicious actor put this in where user-defined URL is, okay? This is actually the EC2 metadata service URL. And if you can put in a role name, and a lot of times these have kind of there's default role names that are attached to servers. So these aren't very difficult to figure out. So somebody put that in to user-defined URL. Well, here's part of the output that would come out. Access key ID and secret access key. Obviously very sensitive information, right? So this is an example of how the input that is coming into your application can expose injection risks in the overarching environment. Okay, so some takeaways here. SSRF can be leveraged to extract sensitive information. Okay, APIs in our surrounding environment pose injection risks. And here's the thing, don't be overwhelmed by the items that you must know, right? By knowing there are things that you don't know, we can create granular whitelisting strategies. And as a little aside, a whitelist is a list of items that we will allow, and then we just reject everything else. And for additional EC2 metadata information, check out the additional resources section in the notes. Now, okay, so we see how different items can interact and basically extract sensitive information from our environment through SSRF, right? We saw the sensitive file. We saw information that was coming back in the response. We also saw those sensitive creds in the SSRF example. Now, somebody might look at that and be like, oh, well, a potential takeaway here of SSRF and semantic injection risks is that, okay, the output is clearly different from our expectations. And since we know what the output should be, why don't we just create a whitelist for our responses or output validation? Why don't we focus all of our time there? Would we be safe? I don't know. You can just think about it, right? Uh, and yeah, we'll see pretty soon here if we'd be safe or not. All right, let's check this out. Now, answering that question, we'll answer that through a real world example. New Relic and the WEBHOOK. New Relic had basically a blind SSRF issue, and this was through their WEBHOOK functionality, and this was reported on HackerOne. By Tung Pun, and you can see a link in the additional resources section, and I'll go into what blind SSRF is in a second. So basically, I'm defining it through an example. Sometimes that's the easiest way to see it. So basically, Tung did a forum post that leveraged this payload, right? And the SSRF really is right here, right? So you see him, this is another way of saying localhost, right? And he is trying to inject port 4352. Now, what Tung realized is that when he did this post request that was really a part of a form, okay, the server would respond with 200 if a given port that was here was either open, or it would respond with a 422 status code if it was closed. So he basically was able to deduce just through response codes some pretty sensitive information that could be leveraged for further attacks. Okay. So All right. So what is this? What is the blind part about this? Okay, because basically we see that there's not. It's basically the we're looking. The blind part is that really actually I'm going to go right here and I'll just go ahead and explain it this way. The blind portion, so blind SSRF is a part of blind injection, right? And the blind portion you can really just think of as we don't have the full response available. And also error messages are turned off, right? So how to really, when somebody's trying to basically do blind injection, they submit true false queries to the application and observe how the application reacts. For example, what Tung was doing was, is this port open? Okay. 200 if yes, 422 if no. Okay. And he was observing the response codes, right? So that was the blind part of it. There wasn't the full response available. He was just looking at different response codes. But people can also do blind SSRF or just blind injection in general through variations in computation times, right? And in different ways, it's totally fascinating the creativity that blind injection really entails. So let's think about this in the context of our previous question, right? Whitelisting output. Well, you could see whitelisting output here would be incredibly difficult, right? Because there's really not the full response is already not really there. It's you basically have to whitelist different response codes. I don't even know. I mean, that would just be that'd be incredibly difficult, right? So basically, the key takeaway here is focus your energy on whitelisting input. Okay. So, course takeaways. For given limited time, I mean, whitelisting output's great as well, but whitelisting input is even more valuable given limited time. Okay. And we're kind of zooming out here, basically on an overarching kind of point of where we're at in this series. Okay, so we've looked at different execution contexts of user-defined URL. We saw it through the shell context, right, previously, and we saw a syntactic injection risk, right? Basically, we put in bash shell delimiters, and we're able to execute another bash shell command. In this tutorial, we looked at that user-defined URL and saw how we could also, just given input there, could also exploit the curl context for a semantic injection risk. And we saw basically how we could go ahead and get a file that's on a given server through the local host interface. We also saw how we could basically get information from our overarching environment through that AWS SSRF risk, right? It's huge. Now, also that user-defined URL can be basically, well, it's being run also within a JavaScript context because JavaScript is the language, right? So we're going to be looking at that pretty soon, and just a common example of how the JavaScript execution context just can be just exploited just in general, okay? And yeah, it's going to be awesome. So what are some of the takeaways given these execution contexts? So for every unique context, right, we must evaluate syntactic and semantic injection risks. So for the shell context, we need to do this. For the curl context, we need to do this. For the JavaScript context, we need to do this. Yeah, so there's some items here, right? And we also need to evaluate injection risks within the overarching environment. And I know this seems like a lot, but just remember that it's really, we're going to be getting into some whitelisting strategies in future episodes that really take the complexity out of this. But the idea is that there's a lot at play here. So we really need to make our whitelisting strategies as granular as possible for our input validation. All right, so join me for the next steps.